about it. You saw how brittle these are. When they're this small, you just barely look at them and they explode. So they can't be dropped. They can't have any stress put on them or they'll just snap. And then these bricks could come forward and fall out like this as you're loading it with wood. So it should keep that from breaking. If wood came in and hit this, like so, it's pushed in pretty tight. So, and it's got fabric behind it. And if this top one's pushed in, it can't really hurt anything. I mean, the blanket absorbs the shock.
What's your other side?
Oh, yeah. So anyway, really enough about that. So, and I've got all these marked so I know they go back the right way. Let's put them out here. I'm gonna flip that before it drops.
What did you make all your fancy cut bricks with?
A couple of low-grade tile cutters, tile saws. And we'll go out and take a look at that after we empty this box. We'll show basically everything we were using. So you can have a nice, fancy wet tile saw, but they're expensive and they're heavy and they're really bulky. So if you're not stationary, if you're not in a shop, if you're doing it for yourself, they're great. And if you already have one, that's even better. But I like lightweight and small, so we'll go see what we did all this with here in a second. All right, so now, which I don't really need to show you taking all these off. You can see how they're layered. We started with these base bricks are full bricks. So this edge and this edge are full bricks that are laying down just like this. So they're just up against the outside wall, and that's how far they come in. And these sit on top of it, and these are 2.5 inches wide. These are 4.5 inches this way. So this sits on it just like that, and that's what you see left. So that being said, you can see that we just have a full brick, and that one's 2 3/4. Full brick, 2 3/4. Then we just stagger the seams as we build our walls. Now had I not had my P-channel like this, if you were building differently, this brick right here would be a brick coming this way. So it would go all the way to the back edge here. So it'd be 2.5 inches to here plus whatever this is. Something like close to like 4 or 5 inches. So that'd be that long. Then you'd have a full brick here that would butt up against this brick face and be 2.5 inches shorter than this one above it. So it'd be this wide plus 2.5. So they would index and stagger in this wall to hold everything nice and tight, just like brickwork. So, but you can see that we've staggered the seams, 2 3/4 full, 2 3/4 full. Same thing on this side. And that's the base, the beginning of the base and the bottom. Then this intricate bottom work. I needed this center section 2 7/8. It's the same width as the opening to the port and the same as our primary air intake opening on our door. So, and those were cut. These could have been full length bricks, but my saw, because it's not a tile saw, won't cut that long, and it gets really hard to do these by hand nice and accurately. So I just chopped the bricks in half, and I was able to do it in one pass and then flip it and do another pass. So basically you got your full 4.5 inches wide here, 2 7/8 here, and then the bevel is what it is, and you end up with whatever this ends up being. So those are all the same. And some of these have got pretty dang tight. Of course, there's also a lot of brick dust building up in here from all the moving around, which is tightening everything up. And this was our little custom front brick, which is just a shorter version, and then I just notched out for the metal tab here. And then these, so these, it was important that this dimension was a certain amount, so my slope bricks would lay right and sit down far enough to be flush with the top of these. So it ended up being 1 5/16 from here to here. And then this was 2 1/4, I think. Yeah, 2 1/4 here, 1 5/16 here. Put your bevel on it, and it's correct. And our little shim piece for the front. And again, these shim pieces wouldn't have been necessary, except we changed the box from a full brick on the back to a split brick on the back. This was all planned to be regular brick length. But sometimes you just got to call an audible in the field. Okay, now if I can get this guy out of here. Yeah, looks like it. Let's see, put that here. I don't like that standing up. Okay. And then my base bricks were made out of a different brand, and the different brands do vary a little bit in size. So these were a little shorter on their long dimension. So instead of 9 inches, they were basically an 1/8 inch short, which was a little unacceptable to me. So we had a bunch of them, and what I did is I just turned one 8 7/8 brick into one 4 1/2 inch brick. So this took 8 full bricks. This isn't a full brick cut in half, but that gave me my 9 inch width. That's because these were on hand, and I mean, I did have to buy a bunch of splits to make all these intricate cuts with, because these are really hard. They're a high fire, really hard brick, and my diamond wheels were having a heck of a time making these cuts. Doing these butt cuts wasn't too bad, but as my blade was heating up, my blade was starting to glow and not cut, and all these bricks were starting to glow, and I was just going to burn the saw up, let alone the expensive diamond blade. So I stopped using those. When I was trying to shape all these with them, got some samples over here. So I did get some of these made, but it was just destroying my saw. It was going to destroy the saw. I would have melted it down. So it was better to buy. These are $159 a piece for either full or split, and we can get them locally. It's a company that makes them themselves, and they're a nice soft fire brick like you'd expect. But anyway, so that's basically just you take all these out. So now we got full bricks here. You throw these in the middle, stacked up. That's what we've got for our Firebox. 1 inch Duraboard on the bottom. The entire base is one piece. In the back of our riser, you can see that's the front of a brick cut, and that's intricate shaped brick, and it's all covered in slip, so it doesn't look like much, but it's hard to tell the shape now. I got to reach in there and smooth that out a little bit. I got little chunks, but now that they're dry, I can clean them up. But you can kind of see back here, maybe the top edge where it's cracking, where the slips. There we go. So you can see kind of where the top edge of the slip is on the octagon riser. So I've got an octagon back there. So if this is your octagon, halfway back. So the front of the octagon is here. The back of the octagon is back there, that wall back there. So if your octagon's here, halfway in from our port, we start a 45-degree bevel up. So it goes back 4 inches and it goes up 4 inches. And what I did is I took a brick and I cut it. So the brick was roughly, the brick is sitting in there like this. So I had to bevel a cut here, I had to bevel a cut here, I had to bevel a cut here and here, and then we shallowed this out. We dished this out almost like a satellite dish. It's dished out wide and then slopes up, and that gives us, as the fire shoots back in here and the gases are shooting back in here, halfway into that riser, then it has that up ramp with the slopes, with the dish action, which shoots it up the walls and mostly around to the right and the left. And then the gases will go in, and then they'll do this, and they'll spiral up. So they go in, and then they spiral up like this. And it's what we call the double ram's horn effect, Because if you look down the riser, if you take the top barrel off and look down the riser on a ladder, you'll see 2 circles spiraling in there. They'll be perfect circles looking like a double ram's horn. And it's spiraling up both directions in the riser at the same time. And then that turbulence is what gives us, plus sucking in the secondary air intake right here, sucking in preheated oxygen-rich air instead of combusted oxygen-poor air from the box cavity. So as it sucks through here, the gases expand, it pulls the suction of the fresh air in with it, and then all that turbulence, it's mixing the fresh air, and then you get your complete combustion in the rest of the riser, and we're off and running with something that can go sideways and heat a bench without leaving a bunch of creosote and deposits. Let's go see. Let's go look over here first. So we've got our bench laid out, which we talked about earlier. While I've been doing this final detail on the box, Jason's been making our structural cob for our curb. So we're doing a 4-inch tall curb all the way around the bench area, and we'll go around the barrel and the box. And that's gonna hold in our insulated cob, which is basically perlite and clay. So the insulated cob is just perlite and clay that'll sit in the middle of this, the bottom 4 inches. And that way we don't lose too much heat going down. It's going to make most of the heat soak in and radiate out and up. So we just started working on the 4-inch curb that's going to surround it, and then we can start infilling the whole center with 4 inches of perlite insulated cob. And of course, as we go, we've got all our little wooden block risers supporting our duct run. We're at 3 1/4 inches above the hardy backer where it comes out of the manifold. So our duct is 3 1/4 inches up on that end, and then we've spaced it up to 4 inches at this T. You don't need that much rise, but it works fine. It was an easy number. So we're still 4 inches here, and then we go to 4 1/2 down at the other end of the other T. And of course, we'll be removing these blocks as we put in our cob, so we don't have fire hazards or charring hazards. And yeah, go outside and see what we're using for all this. So this is a little Ryobi 7 1/4 inch compound miter saw. It's only a single bevel, which means this only goes that direction. I can't go this direction. Well, I mean I can, but it still cuts 90 degrees. So the miter, of course, is this direction, this direction. This is the bevel. So that's why I couldn't do those long bricks with the bevels on them, because if you want to do a bevel like on the floor of that brick, I would put it like this, and then I could chop down, it'd come out to about here, and then I could flip that brick and take my bevel the other direction and come in this way and finish that cut. But I can't do that here, so I was having to do them by hand with the angle grinder with a small diamond blade on it, and it's just, I needed it to be more precise than I can do on that. I'm pretty good with my hands, but that was asking a lot. So you just cut those bricks in half, and then it's real simple. We just put I can throw that sideways. And this is not a very precise saw. This is not, I'm not using this saw because it's fancy and extra accurate and precise. It's a really cheap saw that if you find them, when they've got too many, or there's something wrong with it, or it's a display model, you can get them for like 40 bucks. That's what I did. I have 2 of these. I bought one full price because I'm mobile, and in my truck it's small and lightweight and portable, which is huge for me. I've got a bigger one and I just never use it, so I'm probably going to get rid of it. I usually don't do big woodwork with shelving or cabinetry, so it's just not necessary for me. So, and then this one was a display model that the stop broke, so you can actually go down and cut. You can see the metal's been cut into, plastic's cut into. It was like that at the store. but they had 2 of them on display, so I talked them into this for 40 bucks. So it's a great, I mean, in one way, this is almost a sacrificial saw. It's only going to last so long doing this work, but it's lasted quite a while. I've done a lot of metal cutting with it, with metal blades. I've done a lot of the brick cutting with it, and you know, as long as you blow it out every now and then, and I mean, and don't, as long as you're not forcing it and overheating the motor, you know, just you run it to sound like you're cutting through wood. You can easily over torque it and bog the motor down while you're doing brick or metal, and you'll smoke it really quick. I mean, then it's not meant to take that abuse. So it's not a motor that's designed to withstand that kind of action. So I have to, I mean, this guide is not truly straight. It kind of bows in like this. So if I have a brick just on this side, I have to adjust my miter. If I put it on this side, I have to adjust the miter. And if it's on both, it's in between. So I generally don't even lock it down. And when you lock it, you can see that moves. So it came back, it moved forward. So I generally don't even lock it anymore. I just adjust. I sight down my blade. I look straight down the blade from the front teeth to the back teeth, and I'll have a line on my brick, and I can get a very accurate cut, literally to within a 32nd or even more accurate than that. So it just depends on the cut, how accurate I need to be and how quick or slow it takes. If I'm doing a non-accurate quick thing, you know, you can kind of, I mean, sometimes I eyeball it. I got this, it's not straight. Rather than mess with this, I kick the brick back like that with my thumb and hold it tight. So, but to do a cut like this, 7 1/4 diamond wheel, and just holding it tight against my back fence. And there you are. Now you've got a cut. And then I can flip it, and I can do the same on the other side. And then for all my little detail cuts, if I'm taking a little notch out of a corner, I do it on this. And of course, I've taped my guard up because I have to do a lot of one-handed work, so it gets in the way. I also generally will disable these extra lock switches. I haven't done that on this one yet. You know, all things that I'm not supposed to tell you to do and you shouldn't do, and I haven't done it. I'm talking here. So, you know, like if I want to put a notch in here, so these things don't catch, and it's a soft material. It doesn't catch on the wheel. You don't have to worry about it grabbing and kicking out of your hand. Wood, it would do that. I've done that stuff with wood. You got to be really careful to not let it do this, because